and we're very excited about this podcast. Today you'll be hearing from two experts in the self-driving vehicle world. First, we'll be talking to Hilary Cain, who's the Director and Group Manager of Technology and Innovation Policy at Toyota North America, doing great things in self-driving vehicles. Next, we have Vasudevan, who's an Assistant Professor in Mechanical Engineering at the University of Michigan, where he's collaborating with a number of companies and doing a number of projects under self-driving vehicle technology. Enjoy! SiriusXM brings all the best commercial-free music plus sports, talk, comedy, entertainment, news, and more right to your car. And with streaming at home and on the go, that great stuff goes where you do. Visit SiriusXM.com to learn more. Hello, and welcome to CES Tech Talk. I'm your host, Jeff Joseph. I'm the Senior Vice President of Communications and Strategic Relationships with the Consumer Technology Association, CTA. We are, of course, the owners and producers of the upcoming CES 2018, coming up January 9th through 12th in Las Vegas, Nevada. And one of the other key themes we expect to see at CES next year is self-driving vehicles and autonomous vehicles. You know, self-driving vehicles hold the promise to save lives by reducing accidents. They can help us revolutionize the way we think about our cities, reduce emissions. But there are lots of questions as we travel the road to our self-driving, increasingly automated future. How are manufacturers maximizing safety of the vehicles and data security? What is the proper role of government as we continue on this road? And maybe most importantly, when will our roadways include self-driving vehicles, or more closer to home, when can I get one? Because I want one. Joining me today to address all these questions and more is Hilary Cain. She's the Director of Technology and Innovation Policy at Toyota North America, where she handles policy issues relating to connected and automated vehicle technology, including artificial intelligence, data privacy, cybersecurity, Internet of Things, and Spectrum. Prior to joining Toyota, Hilary was on the staff of the U.S. House of Representatives Committee on Science, Space, and Technology, where she served as staff director of the Subcommittee on Technology and Innovation, where she worked on matters relating to competitiveness, technology, and innovation, and she also previously served as counsel to that committee. Before joining committee staff, Hilary served as the legislative director in Ways and Means Council for individual members of Congress. So great history and experience in innovation policy. Thank you for joining me, Hilary.
Thanks for having me.
Welcome to our podcast on this lovely day.
Very excited.
So let's just start at the beginning. How do you define self-driving vehicles? We talk about the 5 levels of automation. Where's Toyota currently stand? Maybe where do we generally stand on this progression?
Yeah, so I think as the name would imply, a self-driving vehicle is a vehicle that can drive itself, right?
That's
sort of at the foundation.
Very direct.
Right, but what's interesting is that self-driving vehicle isn't some sort of monolithic thing. There are a lot of different flavors of what makes a self-driving car. And to your point about these sort of levels, according to SAE, which is formerly the Society of Automotive Engineers, there are 5 levels of autonomy.
Okay,
right?
5.
So level 1 autonomy is what you see in a lot of vehicles today, right? So that is a system that can do some of the steering for you or some of the braking and accelerating for you. So think lane keep assist or adaptive cruise control. A level 2 system is one that combines those two things. So it can do some of the driving for you and some of the braking and acceleration for you and some of the steering for you, but only some of the time. A level 3 system is a system that can do all of the driving for you, all of the steering, all of the braking and accelerating, but every once in a while it may encounter something that it cannot handle and may ask you as the human driver to take over driving for it.
That's level 3.
That's level 3. A level 4 system is a system that can do all of the driving for you, but only in certain places.
Such
or
as?
Certain geographies, a particular city. Or maybe only at certain times of the day, like day but not night. Or maybe certain weather conditions, sunny but not snowing. And then a level 5 system is a system that can do all of the driving, all of the time, anywhere, any place, any weather condition.
So we're sort of, 2 to 3 in general?
Right, so in terms of the technology and where we are, I don't think it's fair to think of this necessarily as a progression. You don't need to do 1 and 2 before you do 3. You don't need to do 3 before you do 4 and 5, right? So there are some developers who are skipping 3, for example, entirely and going straight to 4 and 5. But in terms of where we are, if you think about it as a progression, you're already seeing level 2 systems on the road today. Think Tesla Autopilot.
Right.
Level 3 systems are probably just around the corner. 4 systems probably also just around the corner, maybe in the next few years. That level 5, that holy grail of autonomous driving, we're probably decades away. If we're being honest.
Wow. And is that, talk to me about that a little bit. Is that because the technology itself is so hard? Is it because the development of the infrastructure? Is it because it'll take some time to sort of have a mix of self-driving autonomous vehicles and driven? Why so long?
Yeah, so I think it's probably a little bit of all of that, but I think it's just the ability to have a system. These systems do not work very well right now in bad weather, and there's a lot of parts of the country, a lot of parts of the world where bad weather is a pretty common occurrence. You've got systems that need to be able to operate in the remotest parts of the country and the world, and those places aren't adequately mapped yet, and it's going to take a long time to be able to map those things. So it's just a matter of having a system that's technology that can work everywhere, anytime, any place, and a lot of technological hurdles to get there.
Does that include the infrastructure? What else is needed? I mean, so you've got the vehicle itself, obviously, the vehicle-to-vehicle communication. There must be some vehicle-to mapping and other communications. Can you just walk us through what that infrastructure might look like?
Yeah, so the reality is that I don't think any developer believes that infrastructure or connectivity are necessarily guaranteed. So I think we're all working on systems that can function in the absence of that type of infrastructure or connectivity. But, and this is an important but, the technology will get here faster, it'll be more robust, and arguably safer if we have things like vehicle-to-vehicle communication and we have infrastructure that can support the technology. And infrastructure, I'm talking mainly about good lane markings and consistent signage across the country. Those things will all be valuable inputs into the system. They're not required, but they will help us, like I said, get there faster and more safer.
And having that consistency,
Exactly.
So each manufacturer can read and sort of make that. So you've been, and we've seen you've been kind enough to be on other CTA panels on
Right.
this. I've seen you speak right often. Why are you and I guess Toyota writ large so bullish on automation on self-driving vehicles?
So the main motivator for us, and I think it's the main motivator for a lot of developers in this space, is safety, right? There are far too many people who die in car accidents on the roads in the United States and throughout the world. Just far too many, and there's something that we can do about that, and autonomy is a key component of that. Another main motivator for a lot of folks, including Toyota, is this access to mobility piece, right? There are a lot of people in the U.S. and around the world who are limited in their ability to get around, and as a result face sort of social and even economic isolation because they cannot drive, either because of their age or because of some sort of disability. And we at Toyota are very much motivated by providing mobility for all, and so that is also a key motivator.
When you think through that mobility for all, was that behind the deal with Uber? Is that part of that?
Yeah, it's all pieces of that. There's a lot of discussion about whether ride sharing is sort of the best or only way to do automated vehicles. I think there's a lot of debate around that. I think there is evidence that because of the high cost of the technology, that if we're able to spread that cost over multiple users, it's a way to get the technology out there faster and give people more exposure to it, because most folks will be priced out of that market.
Right.
But whether ride sharing is the only way to do this, I think is up for debate. I think at Toyota, at least, we see that there could still be some role for personally owned automated vehicles, either maybe some of those lower level systems we talked about, maybe in rural or sort of ex-urban areas, for example, or maybe even over time as the cost of the technology comes down.
It may be too early in the process to talk about this, but have you thought about that pricing structure? So maybe at entry level you have level 1, and for premium vehicles it's the hopefully someday, maybe sooner than 2 decades, the level 5 and associated pricing with that.
Yeah, I don't think that we've talked publicly about any of our pricing strategy around this stuff.
Maybe that's just a different way. Do you have a sense of how affordable will this technology be for consumers as we look at that timeline?
Yeah, so cost is a challenge here, right? So when you look at some of these, test vehicles that you've seen out on the road, the cost of the sensor suite is sometimes, oftentimes more than the cost of the vehicle itself. Right?
Do you have a sense of how many, like the average number of sensors in your current prototypes?
A lot. There's a lot.
A lot.
And they're
Dozens.
they're all expensive.
Yeah.
And so I do think that this cost factor is a major concern for a lot of companies in figuring out how to democratize the technology, so to speak, and not just have it be something that's available to those at the top of the income scale.
Because you really need to integrate over time.
Yep,
It's gotta
absolutely.
Make sense. See,
And then safety isn't just a problem for wealthy people.
Right,
Right,
exactly. We'll come back to the safety issue because that's so key here. But even before we get to that point, well, maybe the angle is, or maybe the question is, where are consumers on this? So we've seen study after study. Some say that consumers are nervous about the technology. CTA, we've done some consumer research and seen other studies that show that they're very excited. Clearly, one part of it is introducing them to this concept, getting them used to it. Hence the ride sharing. What are you doing in terms of preparing your customer base and thinking about some of those consumer challenges, those consumer concern challenges?
Yeah, so this is a really interesting issue, and I don't know which studies are right. I'm going to assume yours are right.
Of course, ours are right.
But I think probably that there's a little bit of truth to all of them, right? And the thing that we have to keep in mind is even if one shows that most people are excited, and another one shows that most people are scared, what it shows us, at its base is that there are some people at least who are excited and some people at least that are scared. And the goal's got to be for all of us in the developer community is to meet each of those consumers where they are, right? So I don't think anyone's talking about forcing this technology on somebody who's terrified by it, but certainly we want to make the technology available to those folks who are excited by it. And maybe over time we'll see some shifts in the numbers as more and more people see it, experience it, have exposure to it. There may be a growing level of comfort, right? That we'll see then translate. But I think as I said, the goal needs to be meeting the individual consumers where they are, and a lot of time and effort is going into thinking about how best to prepare and educate to your point customers about the technology. And some of those efforts are focused on sort of this demystifying the technology. To improve consumer acceptance. But there's also a lot of work, and I think this is important, being done on how to explain these various flavors of autonomy to customers so that they appreciate the capabilities and also the limitations of the particular system that they are experiencing. So in some of these lower levels, level 2 and level 3, there are some significant risks associated with over-reliance on the system. People thinking that the systems are more capable than they actually are. And so we do need to figure out how best to also communicate this type of information to various consumers.
To really understand what canning, these are not super vehicles yet.
Right, and as these vehicles the technology gets better even in these lower levels. We talk about this level 3 system, which may sometimes hand operation back over to a human driver. As those systems get better and better, that handoff, the car actually handing off operation to the human, is going to happen less and less frequently, right? And so then you as a human driver, you suddenly get used to not having to take over operation. But then someday, somewhere, somehow, that vehicle may then need you to step in. And if you're sort of used to not stepping in, it's sort of harder to re-engage, if that sort of makes sense. So we've got to figure out how to get that piece right as well.
Well, and I suspect you're thinking about if I go into this automated vehicle, there is a certain expectation, and if I have to take over at some point, I can't just sit there and play on my phone. I've got to pay attention. I've got to be engaged because I may have this handoff.
In some of these systems, like a level 2 system, absolutely. Right. A level 3 system, just so you can be on your cell phone, arguably. You could even sleep in a level 3 system.
I can sleep in the car.
Right. The way a level 3 system would work is it would have to give you enough notice that you're going to need to re-engage. So we'd need to say, hey, driver, 5 minutes up the road, I'm going to need you to take over, so put your phone down, wake up, whatever it may be. I'm going to need you to get ready to re-engage.
Wow. That's incredible AI. That's unbelievable.
Fantastic.
So we talk about safety. We've certainly seen there's been some news coverage of some accidents. Can you put the frequency of these accidents, these incidents, in context for some of our viewers? Perhaps that might be helpful.
Yeah, and it's sort of hard to say. I mean, we don't have a lot of real world data. And what we've often seen is some of these accidents involving self-driving test vehicles has been not the fault of the self-driving
Right.
vehicle, but somebody crashing into the self-driving vehicle. I don't know that we have enough real-world data to know. It's been infrequent. I mean, there's been millions and millions and millions of miles that have been driven by these vehicles around the country in these testing phases, and we've seen just a handful of accidents. Again, mostly somebody else crashing into one of them.
Right. But I think it's important for people to understand that they see the headlines, but they don't necessarily realize what the context was or what actually happened, and the fact that these vehicles are going through extensive testing with millions and millions of miles being built. And the more that they have these incidents, the smarter they get.
Right, absolutely. And we also have to keep it in perspective, which is, there are a heck of a lot of accidents that are caused at the hands of human drivers, every day. And so, the goal needs to be safer than a human driver, and that's not, an incredibly high bar to achieve.
I don't know how you drive, but okay, maybe for myself. But so when you talk about that, though, there are certain things. Yeah, how are you dealing with, and how's the AI dealing with those sort of quick snap ethical decisions we have to make? How's a self-driving automated vehicle going to decide between hitting the baby carriage or hitting the dog, to use the proverbial?
So this is a really interesting discussion, and certainly one that we need to have. But I also think we have to keep these sort of situations in perspective, right? So we rarely, as human drivers, encounter these types of situations. I don't know about you, but I've never had to choose between hitting a baby or hitting a dog.
Thank God.
And I've been driving for a number of years, right? So, we have to keep it in perspective. This is not a common occurrence. Mm-hmm. Even so, this technology's got to be prepared to deal with those types of situations. And generally, I think the way this is working is folks are training their AI to make the same decision that most average, reasonable human beings would make. So the scenario you've given me is a pretty easy one, right? Most humans, I think, would hit the dog rather than the baby, right? Where it gets harder is if it's a baby or a 26-year-old woman, right? Mm-hmm. Which one do you hit then? And we get asked those sorts of questions all the time, and I think it's a really good sort of philosophical exercise to go through, but I don't know that there's the right answer there. Mm-hmm. What would a reasonable human being do in that situation? Hit the baby or hit the woman? Neither of those is a good choice.
Right.
And I don't know that we would get universal consensus around one particular choice over another. So again, I think it's important that we have these conversations, and we need to make sure that there's pressure on the AI developers to develop these systems to sort of that reasonable person standard.
Right.
But we also have to accept that there's not going to always be a clear answer
Sure.
for a human driver or for an AI in a lot of these situations.
So that's fair. So that may be an extreme case, but certainly we have to make all sorts of decisions in the course of our driving career, and in the course of a driving few minutes. Do I, speed past this car and trust that I can see as best I can see around it? Do I? You have to make those sorts of choices. So maybe at a more common occurrence level, that's relying. Are we still sort of relying on statistics and looking at incidents and decision making by the typical human, or is the ability for these machines to continue to learn? How are we addressing some of these concerns?
So you're right. So the AI, this is about training the AI, right? It's about training the artificial intelligence, and the goal here, and why you're seeing folks doing these millions and miles of test miles on public roads. You're also probably less aware, but there's a lot of work being done sort of through simulation and that sort of thing. And the goal of those activities is to expose the artificial intelligence to as many of these wacky situations the system may encounter over the course of its life, and have it learn from those. And then, as you have more and more of these systems learning, then the systems that come next are even smarter, and then they're smarter, and then they're smarter. And the goal is to expose all of them to as many of these baby carriage versus 26-year-old woman versus speeding around a vehicle to get through an intersection. All of those scenarios need to be fed into this AI to train it to be as smart as it can possibly be.
Is that sharing occurring across manufacturers, or you sort of is Toyota off doing it here and Nissan's off doing it there?
Yeah, so there's a lot of discussion about the potential value in sharing that type of scenario data. There's a lot of work being done, a lot of discussions behind the scenes that are underway about how you would do that, where you would do that, making sure that data would be useful for developers, but maybe wouldn't be used by other folks for sort of different purposes, right? A lot of T's that need to be crossed, I's that need to be dotted to figure out what such a system would look like. But I think there's generally a lot of there's consensus around the value of figuring out a way to do that.
And hence this feeds into this 20-year to a couple decade timeline.
Right.
Before
We'll all get there a lot faster if we share that information.
The more information
so
you
it's
have.
a societal benefit, arguably.
Well, look, we're going to wrap it here a second, but before I go, we're only a few weeks away from CES 2018. You'll be there, I'm sure.
Absolutely.
Speaking,
I
hopefully. Never miss it. Great event. What do you think we'll see in terms of new advancements towards automation, towards self-driving vehicles? What are you looking forward to at CES 2018?
Right. So I think what we're going to see is more evidence of a transition from autonomous vehicles as a research project to autonomous vehicles as sort of a production vehicle, right? So I think we're going to see evidence of folks transitioning out of research and into sort of their business models and production sort of strategy. And I think that's going to be really exciting for folks to start to get a sense of what this is really going to look like when it starts to hit the U.S. market. I think you're also going to see a continued focus. I think we started to see this last year, and we'll still see more of it this year, about the user experience within these vehicles. So I like to make the point that some people prefer one type of smartphone to another type of smartphone, and most of the time the smartphones do basically the same thing, but you like one over another because you like the user experience of one, right? There's something about the interface or the experience that draws you towards one device over another, and I think that's going to be sort of what we see play out in vehicles in the future. If they're all sort of self-driving and there's not really a distinguisher on safety or performance anymore, it's really going to be about how do you feel when you get in that car and how do you interact with that car. So I think we're going to start to see, continue to see a lot more focus on the user experience within the autonomous vehicle.
Cool. So you can really begin to reimagine, as we've seen at CES with some manufacturers, including Toyota, reimagine what that vehicle interior can look like.
Right, exactly.
If you don't have to be at the wheel full time.
Right. And how does the AI communicate with you and all that sort of thing? I think it's the wave of the future, and I think car manufacturers and others are realizing that that's going to be where we're going to compete with each other in the future. So you're going to see lots of exploration in that space.
I get a big screen TV and a keg in mine?
Sure, let's do it.
That's awesome. That's perfect. Well, great. Well, we look forward to seeing you at CES 2018 coming up in January. Thank you so much. My guest today has been Hilary Cain with Toyota. We've been talking about self-driving vehicles, and I'm putting in my order today.
Awesome.
For 20 years from now, or however fast it may come. Thank you for joining us with CES Tech Talk. Don't go anywhere. We'll be right back after a few words from our sponsor. Listen at a whole new level with SiriusXM. It's the widest, deepest variety of commercial-free music. Plus, it's the brightest stars, most amazing sports, funniest comedy, most complete news coverage around, and more, delivered right to your car. And with streaming available at home and on the go, you can get your groove on wherever you are, because all that great stuff and more goes where you do. Yeah, it's awesome, right at your fingertips. Visit SiriusXM.com to learn more. We are just mere weeks away from CES 2018, the greatest show on earth. And there's always the best, the greatest, the latest in technology at CES. And one of the technologies that has been really grabbing the attention and dominating the conversation around CES in recent years has been the conversation around self-driving vehicles or autonomous vehicle technologies. In many ways, the auto industry is where the smartphone industry was just before the iPhone, on the verge of this amazing revolution in technology. Driverless car technology or self-driving car technology has the power to transform our transportation networks, and maybe even more importantly, a national shift to self-driving technology could eliminate an estimated 90% of the more than 32,000 vehicular deaths in the U.S. each year, 32,000 deaths in the United States each year. For the past several years, self-driving technology has been among the star attractions at CES. Almost every major auto manufacturer has used the show to introduce or promote their advancements towards self-driving vehicles. If you haven't done it, it's an unbelievably awesome experience to sit in the car, watch it drive itself, make turns, and maneuver around obstacles. When you actually sit and experience it, the possibilities become evident. While some find the prospect of being chauffeured around by their car itself a bit unsettling, CTA research shows that while people are highly satisfied with current advanced technologies to enhance driving, they love the benefits of self-driving cars and want to buy them. 82% of consumers rated reducing accident abstinence from aggressive driving or driving under the influence of drug or alcohol is the most favorable benefit. Another 80% ranked an anticipated reduction in insurance rates is the second most favorable benefit. The most direct evidence that consumers have an appetite for self-driving cars comes from asking them specifically about test driving or owning a car. They very much want to. In our research, 70% of drivers express interest in test driving a driverless self-driving car, and more than 60% express interest in replacing their car or truck with a self-driving vehicle. So the next question, of course, is when? Until 2 years ago, forecasts for the introduction of self-driving cars varied widely, but in the last couple of years, statements from manufacturers made at CES and beyond show that they expect some widespread availability of these vehicles just in a few years, around 2020. But of course, the road to innovation is always filled with potholes and speed bumps. How will this new tech environment impact employment of truck drivers, delivery services, taxis, and are consumers truly ready? That's a lot to think about. So here to help us parse through this and discuss this with me today is Ram Vasudevan, the assistant professor in mechanical engineering at the University of Michigan. He's a noted leader in robotics research and driver modeling. He received a BS in electrical engineering, computer sciences, an honors degree in physics, an MS degree in electrical engineering, and a PhD in electrical engineering from Berkeley. That's pretty impressive. And he also has done postdoc work at the Locomotion Group at MIT. He's a frequent speaker on robotics and self-driving vehicles. Spoke with us at South by Southwest just earlier this year. That's a lot. I'm going to stop talking, and start asking questions. So welcome, Ram. Thanks for joining me today.
Yeah, thank you for having me.
Awesome. Well, let's just start with the basics. Now, how are companies defining self-driving vehicles versus connected versus autonomous? I know there are different levels of autonomy. Can you walk us through those levels and sort of how we're seeing different companies define these terms?
Yeah, so it's actually surprisingly confusing, and there's sort of a variety of different standards that folks have set out there. What I would say is there's sort of two levels, level 2 and level 3. This is according to sort of the SAE, that is the Society of Automotive Engineering standards, that are basically semi-autonomous vehicles, which means that they do things like lane keeping and adaptive cruise control, and they're really fit for sort of highway driving. And basically, these are the types of technologies that you would see on, for example, autopilot that Tesla has sort of sent out into the world, and GM has in their Super Cruise, for example, now that they're putting out. And so these technologies are not perfect. In fact, they acknowledge that they need human supervision to really be able to work out in the real world. And what they're able to do is take over some of the more boring parts of driving, and they operate more or less without any supervision until they need some help. And what that means is that they ask people to continue to pay attention, and they may turn off, if after a few seconds or maybe a few minutes, a person stops paying attention. And the way that they measure that attention differs by the car company. Then level 4 and level 5 are sort of 2 degrees of fully autonomous. Level 4 is what people call geofenced autonomy. So the idea is that if I'm working in a small city that I have a really great map system for, and it's really great weather, and maybe it's during the day or at a time of night where there isn't any problems for me, or maybe there isn't any snow on the ground, well, then these cars are able to operate completely independently without requiring any driver. Level 5 is sort of the holy grail. It's basically the idea that the car can just be set down anywhere in the universe, maybe anywhere on Earth to start off with, and it can drive itself without requiring any help at all. So level 5 is something that many, many people aspire to. I think anyone who's working in this space would acknowledge that that's far in the future. Much of the stuff that you're talking about in your introduction about people being able to put out self-driving cars maybe by 2020, they're speaking about level 4, that is working with a really high-definition map of a particular environment, and something that they've gone over these roads over and over and over, and they rely on really nice weather and having really nice roads themselves to be able to operate in those situations.
So that's the immediate future. That's that 2020 goal is to have that level of self-driving, but in a, for lack of a better term, a familiar environment, a well driven, well researched, well recorded, data analyzed environment.
and what I'd argue, very pleasant environment. So something where they're, not necessarily Michigan, let's say, on a winter's day, but maybe something like Arizona, for example, on on any given day.
Well, that's and I assume what level 6 and 7 are the flying vehicles for your universe. Yet to come.
Indeed, yeah. Yeah. There's a way out there. Maybe that's the Star Trek, Enterprise going out there.
Should we be around long enough to see level 6, 7, and 8? But your point about this familiar terrain raises some interesting questions about a key part of this transition is real world testing. Driving Highway 101 in California is different than driving, to your point, an icy road in Michigan or the streets of Manhattan. I know I understand the Department of Transportation has set up some testing areas, but are they sufficiently diverse, and are states and localities providing sufficient opportunities to do that type of real-world testing?
Yeah, so at the moment, the Department of Transportation has set up about 10 proving grounds where basically these are places where we can send out autonomous vehicles and get them tested and basically assess what it means to ensure the safety of these vehicles. But in the meantime, I mean, to some, to at least researchers' benefit, and I think the benefit of everyone, car companies and universities have been pushing further and basically been driving these cars out in the real world. And some states have been more open about that. Some states have been less flexible on that. But in either case, they've been looking at trying to expand the testing out in the real world beyond these proving grounds. And that has provided sort of the diversity that we care about. Hopefully, I mean, there's a federal standard that people are saying will come out and will set the guidelines sort of more broadly on what testing will look like. And I think that's going to be really exciting and allow us to really just go out there and drive everywhere. The real question then is, how do we actually certify these things? And that's really hard. That's kind of an open question. We don't have a great answer on how do we actually ensure that these cars are safe, or what it means for us to really even think about sort of the liability issue. That is, if one of these cars gets into an accident, well, then sort of who's to blame? Is it the engineer who wrote the code? Is it the person who maybe stepped in front of the car, maybe accidentally, that got hit, but maybe it's their fault? Well, where does the blame lie in that instance? And that's an even harder question.
That's a great point, and it's a harder question in terms of liability. How are insurers beginning to talk about are they beginning to talk? I mean, they must, right? It's about their bottom line. How are they beginning to talk about those issues and identify who is responsible?
Yeah, so I mean, I think I'm not an insurance person, but
you have enough degrees and everything else, so we'll let you pass on that.
For sure. I mean, what I would argue is that they're thinking hard about the ways that we can resiliently test these systems. So, for example, at the beginning, you described this fatality statistic, which was approximately 30,000 fatalities in the U.S. per year. The incredible number there is actually, how many fatalities occur per 100 million miles driven in the United States. And that's actually a really small number. And so it's one fatality per 100 million miles driven in the United States per year. That's incredible.
Can you repeat that again? That's amazing.
When humans are driving, it's one fatality per 100 million miles driven in the United States.
Wow.
And that's extraordinary. It means is if we're going to lay claim to the idea that we're going to reduce fatalities by 90%, I mean, we're really going to have to drive these cars pretty aggressively around. And that doesn't mean just driving in Mountain View or driving in Phoenix or driving in Pittsburgh during the summer. It means that we're going to have to be thinking about driving everywhere, in the winter, in Manhattan in a really crowded time, and Michigan maybe when it's very cold. And that's really how we get the power in these statistics to make the claims like the one where we drive down fatalities by such a big number. So, I mean, things insurance companies are thinking about are there ways for us to test features of the algorithms that appear on these cars? So, for example, can we test the pedestrian detection algorithm that's running on these autonomous vehicles and do it in simulation, where basically what we're doing is running it every night on 100 million miles of data that we've collected or generated in some way, and then validate that these algorithms are able to identify people at a high enough accuracy across those 100 million miles to be certified as safe. So that's one way we can try to overcome some of these problems. But certainly that's a that's something that many of the car companies are thinking about, many of the insurance companies are thinking about, and I'd argue researchers and the federal government is thinking about how to set that standard appropriately.
We've talked a lot about the challenges and some of the concerns around it, but the truth is there's a lot of promise here as well. For example, I've heard you talk about the potential to use cars, self-driving vehicles, to track flooding and weather patterns. Beyond the safety implications, what are some of the other benefits and promises of self-driving technology?
I certainly think that in terms of pollution reduction and basically more effectively deploying systems that are, driving people from one place to another. So, in terms of mobility more broadly, for example, I drove here to my office, and that car is just going to be sitting there all day doing nothing. What that means for me is that I've made, let's say a $30,000 investment in something that I use only about maybe 2 or 3% of the day. That's a huge investment. It's not necessarily something that's the most cost effective. So if we can think about how do we start now using these autonomous systems that exist out there and make sure that we're actually getting our bang for our buck, and thinking more broadly about how do we ensure that these systems that are, may take a lot of effort in terms of products from the environment to create, how can we actually ensure that we're creating just the right number so that we're not polluting or requiring too much out of the world in order to actually get something that we're only using for 2% of the time. It has the potential to really revolutionize the way we think about products as a whole.
That's cool. I can hear the excitement in your voice. We're going to see you at CES this year?
Hope so. It's a lot of fun.
Any sense of what we may see, or as we think about the road to self-driving, any sense of what companies may show, or how much further along we may be in the transition?
I think you'll have to come out and check out the booth. I'll let it be a surprise. But I think what you'll see is that everyone's been taking steps. I think the exciting thing about CES is that you go around and you get a very high level perspective of where all of these companies think the space is going. And I think that's really exciting because you don't necessarily have to walk, or fly, between these different companies. You basically get to walk for 2 or 3 minutes, and you now see a completely novel perspective on these problems. And basically all of the major players are there, which can be really exciting. So as a researcher, it's a lot of fun. As a kid at heart, it's great to see all of the fun toys and whatnot roaming around on the floor too.
That was an awesome setup. Thank you so much. Mm-hmm. We are looking forward to CES 2018 in just a few weeks, right around the corner, running January 9th through 12th in Las Vegas, Nevada. My guest today has been Ram Vasudevan. He's assistant professor in mechanical engineering at the University of Michigan, doing incredible research in the areas of self-driving vehicles and robotics. Really cool, exciting stuff. If you need more information on CES, please visit ces.tech, where you'll find information on self-driving vehicles, smart cities, connectivity, 5G, 4K UHD televisions, and all the incredible technologies and innovations you'll see at CES 2018. I'm Jeff Joseph, the Senior Vice President of Communications with the Consumer Technology Association, and thank you for joining me today on CES Tech Talk. SiriusXM brings all the best commercial-free music plus sports, talk, comedy, entertainment, news, and more right to your car. And with streaming at home and on the go, that great stuff goes where you do. Visit SiriusXM.com to learn more. Thank you for listening to CES Tech Talk. Don't forget to subscribe to this podcast so you don't miss an episode. You can get more information on the CES show in January at ces.tech. Our show is produced by Tina Anthony. John Lindsay is our sound engineer. And me, I'm Jeff Joseph.